All right, let's go and take a look at multiplying and dividing of negative numbers, especially this idea of why does a negative times a negative equal a positive? Well, first, let's think about multiplication, right? Remember, multiplication can be seen as repeated addition. So 5 times 3 is 3 plus 3 is 3 5 times, right? So there we go. How about 5 times negative 3? Well, that's negative 3 5 times. So we could see using our counter or chip model, we could see that this positive times a negative will be a negative. What about negative 5 times 3? Well, I think one way is just to remember associative property. That could be one way to think about it. That negative 5 times 3 is just three groups of negative 5. But if you want to actually look at it, negative 5, it's hard to say take away, right? 5 groups of 3. So we can think about it that way. Take away 5 groups of 3 blue counters, right? So there's 15 blue counters and 15 negative together. That's a 0. And so if I take away 5 groups of these 3, if I take away those 3, I'm left with 15 red or negative 15. So that's a way to think about it, right? This value is 0. Then it's when you take away those 15 positive, those 5 groups of 3, you're left with 15. So that's another way to think about it. Another way, again, I think about it is I could also conceptually think about is 3 times negative 5 because associative property, which we learn holds for integers too. But another way to think about it. Another way to think about it is through patterns. How about a negative times a negative? Back to this pattern approach. Take a look when we zoom in here. Take a look at the pattern. 2 times 4, 2 times 3, 2 times 3. You can see it goes down by 2. 2 times 0, 0. So 2 times negative 1 has to be negative 2. It follows the pattern. Negative 4. Then 2 times negative 3, right, is going to be negative 6 as we go ahead and think about that. There's your negative 6 right there. So looking at that, we can then see, again, how about this other pattern here when we have negative 2 times 4, negative 2 times, you might hear a dog barking outside. My parents' dog, sorry. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. Negative 2 times 1 is negative 2. So you could see this pattern. Negative, it's going down from negative to positive. And so negative 2 times negative 3 would be positive 6, right? Kind of looking at the patterns that emerge. So it makes sense then that a negative times a negative is a positive. Now we could use that same idea of take away two groups of negative 3, right? So if you have let me put two groups. There's the positive, right? There's the two groups of positive. And then if you have your, let's do that here. So again, looking at this problem here, negative 2 times negative 3, the one that is right there, this one, right? When looking at that, we could say take away two groups of negative 3. So I'm going to take away that one and that one. What are you left with? Set theory, positive 6. Another way to think about it. Of course, we have rules, and so sometimes students memorize these rules, right? When the signs are the same, your answer is always positive. Maybe that's just easier to remember. When the signs are different, your answer is negative. So it's just memorizing, but this gives us a conceptual reason of why that would make sense, right? Looking at the patterns, looking at the chip models or our set model approach, right? We could see why then these rules make sense, which then leads us to some of these rules. Anytime 0 is 0, a positive times the negative, the way you think about it is just multiply the two numbers and keep the negative, right? Because when they're opposite, the answer is negative. When two numbers are negative or positive, the answer is just A times B. So it's another way to think about it. Leads us to these examples here. 4 times 0, 0. 5 times negative 5, right? It's just 5 times 5, but opposite. 4 times negative 4, right? It's just 4 times 4 because we know the answer is going to be positive. So just using the rules, you can see I'm just following these rules here that we have here. Or again, you remember kind of our the rules of sign numbers, right? The positive, negative, or you can kind of remember the patterns that we talked about. Negative 4 times positive, that's negative 20 times negative 6. It'd just be 20 times 6 or 120, so forth. That's a negative right there. We learned earlier, multiplying by negative 1. We learned, remember, a negative of a negative like this. Right, that's just opposite of 3. That's it. So the same case, if I'm multiplying negative 3 by negative 1, it's the same as basically its opposite. So negative multiplying negative 1 is the same idea as taking its opposite. So using that theorem, we can go ahead and solve problems like this. Opposite of 9, negative 9. Opposite of negative 6, positive 6. Opposite of negative 1 is positive. 1 times 3 is 3. And it leaves us with our properties for multiplication, like we said. Commutative property, associative property. Again, for whole numbers and for integers, it works. Anything times 1 is itself. Distributive property works. Here's kind of one we use in algebra a lot. If AC equals BC, then A equals B. So we can divide both sides by the same number. Something to think about, right? So again, if I say 2, let's just leave it there instead of talking about algebra, but that allows us to do some stuff in algebra. And then anything, if when you multiply two numbers that equals 0, then one of those numbers or both have to be equal 0. So if I say A times B equals 0, that is only true if A or B has to equal 0, or both are equal to 0. That's the only thing. Okay, that's it for multiplication.